Good morning.
Morning.
Just door and get dogs and cats out. Hope everyone is having a good gloomy day.
Got to wear green.
What's that?
I forgot to wear green.
Uh-oh, somebody pinch him. Well, I got my green shirt on, got my green coffee cup. I got
my
green eyes.
gum pack. I'm green with envy.
There you go. Yeah. Well, I'm Irish through and through, so I guess I'm as good as it gets as far as a leprechaun is concerned. Okay, so the other day we were talking about advanced framing, and I wanted to continue that. I know I had to fly through the end of that a little bit. Where am I?
Will you have time today to go over that quiz, or are we going to wait on Monday?
The building envelope quiz.
Yeah.
Yeah, we can go over that.
I figured out what I was doing incorrectly, why I kept getting that weird error where I couldn't get into it. I wasn't scrolling down far enough, and I was clicking the previous test, and that's when it was, obviously locked out because it was already over.
Yeah.
Then I realized, whoa, I'm not going down far enough, and clicked in the building envelope. Once I figured that out, I'm like, okay. It only gives you that once it's, over and then, locked out.
Right, right.
Here I was blaming Moodle, and it was my fault. But Moodle does screw up once in a while.
Operator error. It happens. Yeah, I mess up too. Okay, number one, all foundation drainage lines must be covered with washed gravel and filter fabric. So we can't use, what is a crush and run? It has fines in it. It has rock dust in it, and it's got everything from basically from rock dust up to probably 1.5 inches rock in it. So it's not, water is not going to drain through that. So we need to have the wash stone. So they take the crusher run, and what they'll do at first, they're going to separate all the rock and into different sizes, because you can buy what they call 57 and I can't for 63, and what they are, they're sieve sizes. So a sieve is basically a big old pan that has a large screen on it that a certain size rock will go through it. And so you definitely want to have what is called 57, and which is washed gravel. It's basically 1 inch to 1.5 inches gravel. And then we want to cover that with filter fabric so that we don't get any silt down in it from our earth around here. An example of an unconditioned space would be, which one?
Crawl space.
Crawl space. Okay, it's unconditioned. Now, this is, in my building science class, this is iffy when you're talking about a crawl space. So really, if it were a sealed crawl space, which means that we give it just a little bit of air conditioning in there to keep it nice and cool, it is a semi-conditioned space. If it's a vented crawl space, it is unconditioned in the wintertime, and it's outside in the summertime, because the vents are open in the summertime and closed in the wintertime. So a capillary break would stop water from soaking up the block and the concrete foundation. So we're basically putting some sort of block there so that it doesn't soak up. And that's, I didn't really talk about that, how to do that the other day. Uh-oh, somebody done stole my pen again. Here it is. How do you do that? And so it's kind of a weird situation. Basically, what we want to do is we've got our footing, and this, I'm gonna tell you right now, this just does not happen nowadays on sites. And we've got our block or poured concrete wall in here, And we have rebar that go in through here and connect the footing to the foundation wall. You know, yes, there's concrete on concrete here, and it's generally not poured at the same time. And that's why we put this rebar in here so that this does not move back and forth. But a capillary break would be added right here by means of some sort of rubber or bituminous material to stop that wicking from coming up into it. So what's that?
Is that more common now? I've never seen that.
No, you know, not unless it's an Energy Star house and they're really I mean, okay, so, you know, in all my years, I've yet to see it. I mean, I've seen it in classroom settings, I've seen it in lab settings, but I've never seen it in real life settings. Danny, have you ever seen it?
I've only seen the drainage mat that was designed to go in under a poured wall like that. So the whole thing was incorporated, but it was a lot like an ICF. The whole thing was a system designed that way.
Yeah.
I haven't seen anybody use any sort of a fabric or metal in between at that point. It's most likely you're going to see it at the top of that concrete wall before it.
You're talking about like the drainage mat that we have going all the way down.
Yeah, I've seen there's a product that they've got that's, you know, basically like a insulated concrete form that's got that capillary break built in at the bottom. I usually see it at the top of the wall under the sill plate.
Got you. Yeah, yeah. Okay, define the U factor. So, you know, is it a reciprocal of R value? Yes, it is. Is it conventionally defined as the rate of thermal conduction through the material? Basically, you know, how fast is it going through the material? Yes, it is. Is it a heat transfer coefficient? Yes, it is. So the actual true answer would be all of these. Okay, foundation drain must be laid with the holes. Somebody answer that because we went over that.
Down, that's the one I guessed wrong when you were describing it.
Okay, down, that's right. One way an HVAC system is sized inefficiently, and I mentioned this, is using the square foot method. All right, in the old days, it was 1 ton for every 400 square feet, and that was super inefficient and it didn't work. So, you know, basically we've got to use the J manual, the S manual. You know, we got to calculate airflow needed for the room, for each room, and so forth and so forth and so forth. So, you know, sizing an HVAC system today is more science than anything.
I'm surprised you didn't put the curb method in there.
What's the curb method?
Well, that's when you walk across the street to the other curb and you hold up as many fingers as it takes to cover the house, and that's how many tons you need of cooling.
Oh my Lord, I've never heard that, but yeah. Oh, that's an 8-ton unit.
That's what I was told in Georgia. You just walk to the other side of the street, and however many fingers it takes to cover the house, that's how many tons you need.
Oh my word, I'll remember that. That's funny.
Some hillbilly came up with that one.
Oh my Lord. Oh, okay, let's see. Seal all duct leaks with
Mastic, that was in the video that I rewatched.
There you go, mastic. Very good.
But I did remember it.
I thought that was going to be your trick question there because, you know, I've seen people mastic over the filter covers and mastic over all of any moving parts. So then you couldn't adjust your dampers and you couldn't get your filter out. And when you said accept those with removable components, I thought, well, I've seen people mastic right over the filter door.
Yep.
Probably want to leave that open.
Well, on the unit itself, you know, if there is no filter in the unit, in other words, you have a filter that is, you know, somewhere else, you've got a return. Yeah, definitely don't do that. But on the unit, like my unit is up in the attic and it has access panels on it. But I'm going to tell you, if you don't mastic those access panels, it will actually pull in air from the attic. So it's very important to do that, even though it's a removable component. But yeah, definitely don't do the filter if, because you need to get to that on a monthly basis. So.
I had a lot of HVAC guys who knew that they weren't going to pass the test unless they covered all the filter door stuff. And then,
Well, that's pretty sad.
They'd tape it all up. They'd tape up the whole unit, and then you'd have to go cut the tape out just to change the filter.
Wow. That's sad. That's sad. Holy mackerel. Yeah. Okay. So yeah, this is a little controversial here. So the R value of a ceiling to the North Carolina Building Code, the proper answer, of course, is not enough information needed, even though there is some, discrepancies in the code. But if you ask any inspector, first thing he's gonna ask you is it a raised heel truss, or have you built a knee wall on top of it? And it goes back to whether or not we're having those crush issues or not. So when we're talking about that raised heel, basically we've got the wall down here, and we have about I don't know, generally it's about a foot or so space here, where this is raised up off of the the double stud here, and we can get all of our insulation without it being crushed. So this would be an R30, since we can get it all the way to the very outside of our building there. So that's why I had that on there like that. R value of a floor, 19. I don't think there was any discrepancies on that. And then the R value, according to the building code, and maybe I should say according to what Hurley taught you. So Danny has explained that yes, we now have an R13 plus 2.5, which would give us, which would take a 1/2 inch piece of extruded polystyrene to achieve that. Notice that, well, I guess they probably changed that for a specific reason, because by using the 2 like it is now, we typically could use expanded polystyrene, the white stuff, the coffee cup stuff, which holds water. It will absorb water where the extruded will not. So that's probably a pretty good choice in doing that. So turn off my phone, sorry. And of course the email is going to sing on my computer too. Okay, when properly protecting a foundation from moisture, what are the proper materials to use, and pick all that apply? So we could stop at code. And so, the code says we got to have parging and a bituminous material, right? We don't have to have, let's see, a drain pipe to cistern, drain pipe, but we do have to have that. Drain pipe to daylight. Silk fabric to covered stone, yes. We don't use crush and run, we use wash stone. All right, so why can we not catch our water coming off of the, out of the foundation? Because it's dirty. By using a cistern, then we stop the flow of water. We want to get that water out, and that's why it goes to daylight. What you see here is code. The vertical drain mat is not code, but it is a proper way of getting that water out of there. Tar paper. You can actually use tar paper, believe it or not. You can use tar paper over in place of the silk fabric. I don't even really know why that is like that, but you can do that. It's in the code. So mortar and sand. Mortar and sand is going to be less protective than the Portland cement and sand. So even though I've seen it and it's hard for the contractor to prove this after it's done, Portland cement is the best thing to use, because it's gonna give you a better seal. on your concrete wall, and it's going to be stronger. It's not going to chip off like the mortar will. And definitely never use crush and run anywhere we're trying to use a drain, period.
Question, is the vertical drainage map the only one that's not code?
Yes, in this particular case, yes.
Okay.
When I was in business, I did the parging, I did the bituminous coating, then I put on 6 mil plastic, and then put the vertical drainage mat on there, just to kind of give it. I put the plastic on there just to give it an extra little oomph. And I don't know, did I talk about a cant strip at all?
Can't spell it, C-A-N-T or?
Yep. I don't remember if I did
I
that or
don't
not.
recall. I mean, the name rings a bell, but I don't know if it's because I read it or heard it from you.
Well, you use them in roofs too. So when you have a parapet roof, then you basically, on a roof, this is made with insulation, and then it's covered with either a built-up roof or a single ply roof, and we haven't talked anything about that. But down here, as we're putting this parging on, of course, some of it's going to fall on the footing down here. So we just take that leftover parging and put it, and it's a CANT strip. And so the cant strip basically just, kind of sheds that water out and away from, because this is the weak point right here. Water will seep right through there. And then if we have a basement and we don't have proper drainage out here, we don't have some sort of plastic in here, or maybe this has pulled back. One of the things that I've noticed that they like to, some people like to put that 1/2-inch piece of felt board. And so felt board is basically tar impregnated paper board. I mean, it's crap. And they'll put it in here because the code says that this concrete cannot touch this concrete. It's got to be separated. But all you got to do is take that plastic and turn it up the wall, and you're done. You've taken care of that. But they put that cant strip in there, and that allows moisture to wick its way up and into the top of that concrete there. So I'm just not a fan of the felt board at all. And so by putting this cant strip up there, then when you put your bituminous material on there, then you have a good barrier there to get that water up and away.
Is it named cant strip because it can't leak?
I don't know. I couldn't tell you. And I'm sure depending, that's what I've always heard in this area. I'm sure if you go to New York or Oregon or California, there's going to be different names for this for sure. And all the architecture that I've ever seen and been taught, even when I worked for different architectural offices, we would note this as a cant strip in the roof anyway. A lot of times we didn't put the cant strip, we didn't draw the cant strip on the footing. It's just kind of it's an extra little measure that kind of helps out. And I'm not even sure that it's in the code, to be honest with you. Okay, the webs of a CMU are considered what?
Thermal bridges.
Thermal bridges, that's correct. When we stand beside of a campfire, we feel heat by means of what type of transfer?
Radiation.
Radiation, that's right. And yes, there's going to be some convection on there, but unless you stick your butt clean over top of that campfire, radiation is going to be the main heat transfer that you're going to feel there for sure. So I do a lot of TikTok videos and stuff on solar thermal and on the bus especially, and I want to get your opinion on this. I'm thinking about doing a video where I have the sunlight coming in, the cat's laying on the sun on the floor, and I say radiation transfer. And then, I've got some bacon in a pan. It's sitting on the stove and the handle's really hot. You got conduction. Then I'm going to get my wife to walk across the kitchen and let out a fart. And then I'm going to have convection. Oh, Lord. Okay. A passive thermal water heater uses blank heat transfer. So this one was kind of, another catchy thing. So yes, radiation is used to heat the water, but because we do have water involved, convection is the better choice. And that's one of them damn DMV questions there. Which one, there's more than one right answer, but which one is the best answer? So in order for it to work, we have to have convection going on for sure. We use a pot to move a cast iron skillet from the stove. I'm sorry, we use a pot holder to move the cast iron skillet from the stove because of conduction heat transfer, because that skillet has heated up the handle. And I was really stupid one time and I grabbed a skillet to move it off the stove, and I don't know, I got about 2 feet away from it before it realized that it was hot. And by the time I had actually set it down, I had the impression of the handle burnt into my hand. Yeah. All right, so I basically listed every possible mold that I could think of that's in a house. And which one is the most dangerous? Well, it's black mold. So what is black mold called?
I don't know how to pronounce that.
The S word.
The S word?
Yeah.
Stachybotrys. Stachybotrys.
Stachybotrys.
Stachybotrys.
Botrys.
Yep. Some people call it stachybotry or stachybotry. So I guess it depends on what part of the U.S. or what part of the world you come from for how you say that. But stachybotrys is the black mold. A leaking pipe, plumbing pipe, is known as
bulk moisture.
Bulk moisture.
Bulk moisture. That's correct.
That's kind of a no-brainer.
The 2 most common roof leaks are
chimneys and vents.
There you go. Improper flashing around chimneys and improper flashing around roofs. So intersecting roofs can be a problem, but generally, because we know that they're a problem, they tend to, really flash those better. Another one that's not listed here, and I didn't want to list it here, is where you have a roof against a wall. So that if you don't do the step flashing properly, you could have some leaks there as well. Primary source, and this should have said of rather than is, primary source of water vapor in air is
air transport.
There you go. Air transport. Remember that, when we had that one little picture, it said 50 pints per heating season in a hole, half-inch hole. So air can pull in a lot of moisture very quickly, especially on a day like today. Oh my gosh, if we got a leak there, then Okay, water in air that moves through permeable materials, in other words, those having perm ratings over 1, is called what?
Vapor. Damn, am I the only one who got all these correct or what?
Vapor diffusion. No, everybody's going to let you answer.
All right, I'll be the brain today.
What's that?
I spent all day yesterday doing this.
Which moisture transport allows more moisture into your home?
Air leakage.
Vapor barriers are placed
warm in winter.
Warm in winter. Very good. One example of air leakage may be
pipe chases.
Pipe chases. A natural phenomenon of air leakage in steel air is called
stacked effect.
Stacked effect, that's right. And I had to put in steel air because obviously, mechanical systems and wind driven are moving air. So stacked effect is a moving air, but it is a self-created natural phenomenon.
Yeah, you went back and re-explained that one just for me with that building with all the stuff on the outside.
Plastic, yeah. With wind-driven infiltration, the blank side can be more leaky.
Negative.
The negative side, that is correct, because all it's doing is moving air out of the way and it has to be replaced. One example of mechanical system driven infiltration might be
The dirty filter, and it took me 5 guesses to get it. I didn't know what the heck. I read and read and read. I
Think
couldn't
about
find it.
this. All right, so and honest to God, when I had a house of that, well, I've still got a house that's got 7 in it. Actually, when I had a house that had 8 in it, we had to really pay close attention to that filter because the HVAC system would come on and you could hear the ductwork go dunk because it would suck it in. So if that HVAC system, if it's got a dirty filter in it, that means it's plugged, it's got a hole, and it's got to try to find some air somewhere else, and it's going to pull it in from the attic or the crawl space or wherever that it can, and it makes it for a bad situation.
Well, explaining that makes sense now, but when I was first reading all this, I remember reading something on the internet, and I don't remember the answer, but basically the garage door was implied because you're opening and closing that and letting the air in. So that's why I chose it the first time. What it was explaining about it. So that didn't even come.
When the garage door is closed, it is unconditioned space, but when it's open, it's outside. When a garage door opens, generally you don't have any suction going on there because the door opens in an upward fashion. However, I have seen houses, apartment actually, that was so tight, and it was actually dangerously tight because it didn't have any type of fresh air infiltrate or fresh air coming into it. When you closed the front door, you would flush the toilet. That's how tight
That's funny.
that was it. And so, I was at ASU and the professor took us over to this apartment, and there was one apartment and it was stuck in the middle and they had super sealed everything else. And he's like, "What's this shit?" And he closed the door and we heard, it was kind of crazy.
Well, I've seen apartments or houses where if you got a front and back door, you can open and close either one and open or close the other one because of the suction.
Yeah. Absolutely.
At first, I thought that one was an HVAC without a filter.
That was my second choice.
Well, an HVAC without the filter is like blowing through a 4-inch pipe. You've got there's going to be no leakage there whatsoever because there's no restriction. There's no, what am I trying to think of? There's no friction, not friction, restriction. I guess restriction is the best term. Yeah, I guess. Yeah. So you've got, it's just, and it's gone. A blower door measures
The leakage at a pressure.
the leakage at a pressure, the cubic feet of air leakage in a house at a certain pressure. Why is it not air changes per hour? Because that is generally a calculation that we do. Now, we do have some blower doors that will go ahead and give that to you, but in order to get that, it has to find out the cubic feet of air leakage in the house at a specific pressure, and then it just does the calculations for you. When performing a depressurization blower door test, the pressure is set to
-50.
-50 because it is depressurization. All right, what is the typical gold numerical to set when calculating an ACH 50? And this went back to what Mark was asking the other day. What is the magic number? Does anybody remember?
Three, I had to go watch the video
There
again.
you go. 3 is a magic number. Yes, it is. It's a magic number.
7's mine.
What is a bad way to stop air infiltration in a home?
Polyethylene.
There you go. Why is polyethylene, why is that bad to stop? You know, I mean, it's got a very low perm rating on it. What's up with that?
I read it, but I forgot.
Because it becomes a moisture barrier that will condensate. So,
Okay.
you know, we need, and I know this sounds silly because we think, oh, we want to try to have a 100% perfect moisture barrier in there, but really we don't. We want to have a semi moisture barrier on there. And that's why we use this house wrap. House wrap works like, what's that material? Gore-Tex material. So, you know, it stops, it prevents massive air movement of water. However, it will allow water to evaporate out. So there's going to be some water that gets into your wall at some point. It's just because of that, you know, that dew point that we're talking about the other day. So we need to get whatever that water is out. We're trying to prevent as much water from getting in there as possible, but it's almost impossible. And by putting a polyethylene barrier on there, then we're actually creating a problem of moisture. And that's what I'm dealing with this bus with the metal is because it's like that polyethylene barrier. I have to come up with ways so that the inside walls stay a little bit airish, I guess you could say, somewhere where I can get the water out of there. All right, so here was that one question that was a little bit funky. When calculating the air changes, the natural air changes of the house, which method is used? We use the higher of the two. So we've got to do both. And again, you know, this one is generally, you know, the people, unless we just have a very large family like I do, then the airflow P generally is going to be lower than the airflow in the building. Blank rigid insulation is the best and has an R value of 7.2. And might I add, this 7.2 is an initial R value. It does settle to about 6.5, and that is polyisocyanurate, isoboard. I had a guy just absolutely bust my balls the other day saying that polyisocyanurate was the wrong type of insulation to use in my bus because it off gases. And I asked him, I said, well, what should I use? He said spray foam. Spray foam off gas is worse than any of them.
Really? Okay.
Yeah.
Closed cell has a chemical blowing agent. If you use open cell, it's got a water blowing agent.
Yeah, but putting an open cell in that bus is like putting a sponge against the wall.
Yeah, it wouldn't be good up against metal.
No. Be driving down the road and all of a sudden my roof fly off. Well, heck, I was going to say something and all of a sudden just gone. Okay, well, anyway, this insulation gives you air sealing as well as reduced heat transfer.
Just spray
foam. Okay. So it does give you air sealing. When damp proofing a basement, which of the following is not code but should be used?
What's the
Drainage plane material. Yeah.
It took me 4 guesses to get that one.
Got that. I looked that one up. It was on the internet.
Well, if it's on the internet, it's true.
That's right. It's really
After a
pretty.
while, I get lazy and tired. I'm sorry.
All right,
the next one.
Here was a question that
5 tries and I still got it wrong.
all right, what is the R value? And I even give you the picture. What is the R value of the framing section. So let's do this right quick.
All right, you got exterior air, and this is where I had, well, it took so many attempts because on the chart, you've got 0.17, which I used several times, but then I got to realizing on the second page, you got, there's a difference between winter and summer.
Yeah, and I should have made that clear.
And I averaged it.
Almost all the time we use winter. Not unless we're down in the tip of Florida do we use the summer calculation. So it's pretty standard throughout, you know, the well, above Georgia, I guess you could say, that we use the winter time, and I should have said that. So these are the we most use is 0.17, 0.68. So let's do this. So we have hardboard siding.
The exterior air is 0.17, correct?
And of course, it's not going to respond, you jerk.
Hey.
That
Oh.
close that. We won't even mess with Excel anymore.
This is the only one I couldn't get. After 5 attempts, I gave up.
Oh, it's on the same one. All right, so we got hardboard siding.
So the fiberboard, is that the sheathing? Which that had to, on the first part of the chart, it was 0.63, but then if you went in on the second part where it broke it down, it had 1.25, kind of like a universal coefficient, didn't it? Irregardless of the thickness. So I didn't know which one to use either.
Right.
That's why I always kept trying different additions to.
Okay, are we going to put in this R13 insulation?
No,
No, because it goes through the stud there. It doesn't go through the insulation.
you had to correct me on that one.
Yeah. Do we put in the gaps? No, because the gaps are over here. So we have in air. Okay, so let's look this up. Down here, we're going to use exterior air, which was at the bottom, 0.17.
Okay.
0.17. And then hardboard siding. So here's our siding material. Hardboard, half-inch hardboard siding is 0.34.
Whoa, now. Get that. I didn't even look there.
Right there.
Okay, wait a minute. Siding material.
Siding material, half-inch hardboard.
Well, see, I was going by the diagram, not the stupid text.
What do you mean?
Well, down here in the diagram, you got sheathing. So that's the reference I used for the chart. So you should have specified what to use, the image or the text. That's what threw me off. No wonder I knew how to.
The half-inch fiberboard is a sheathing. I mean, OSB is a sheathing, plywood's a sheathing. Sheathing means substrate.
I wasn't specific enough. Okay. Damn it.
Okay, so half-inch fiberboard. So here is fiberboard under the sheathing materials, and we have half-inch fiberboard, which is 0.1 or 1.3. Let me just, I can't talk. There you go, that one. All right, so when we're talking about the 2x4, you know, if we look at the picture, see how we're going through the 3.5-inch side of it. So when we go here in the construction material, it gives us the 3.5-inch side, and that is 4.38.
Yeah, got that. What was the hardboard siding again?
1.32. Oh, the hardboard siding was 0.34, sorry.
Wait, you got hardboard siding and then 1/2-inch fiberboard.
Yes.
Oh, what, okay,
And then the 1/2-inch gypboard is 0.45. Where is that?
wait, what's the 1/2-inch fiberboard?
1/2-inch fiberboard is 1.32. Okay, so here is the 1/2-inch gypboard, 0.45. And then lastly, we have the inside air in winter is going to be 0.68, 0.68.
Okay. The gypsum was 0.45?
Yes.
Okay, at least I got that one.
So we should have had an R of that of 7.34.
7.34. Oh, wasn't awful much. So from now on, go by text and disregard. The image was just to give you a reference.
There you go. Yeah, always go by, if you're taking my building science class, definitely, because I use this for everything. I basically put that up there so you have something to look at, because if I just told you to do the framing section like you throwed in the insulation. So that's why I drew this picture and put it up there so you would look at that and say, oh, I'm not going through that.
Okay. So 3.4, 1.32, 4.38, and 0.45. And okay, and the airs were, let's see, 0.17, which I had that. The air's the only thing I got. Well, got the framing correct. And the inside air is
0.68.
So I screwed up the siding and the fiberboard.
Yeah.
I didn't look up the specifics on the car.
Yep. Okay, so the next question is, what is the total R of 5 inches of sprayed in foam? So this was really kind of a simple equation, a little math going on there. So basically, you've got to find where the sprayed in foam, the polyurethane sprayed in foam, is 6.25 per inch. So, basically we're just saying 6.25 times 5. Bam, there's your answer, 31.25. Windows and doors are sold by a U factor rather than an R value. So if U is equal to 1 over R, what is the R value of a window having 0.44 U? So basically it's just saying 1 divided by 0.44 equals 2.272727. So it has an R value of basically 2.3. And I ask you to put it to 2 decimals. So it would be 2.27. Just so you know, any of my tests, 2 decimals. You don't need to put, you don't need to copy that and put that whole thing in there. I round off to 2 decimals. Okay, using a fall day of 75 degrees and 50% relative humidity, how many degrees would it take to rapidly fall in order to reach the dew point? Right click on the image and open it in a new window. So that means it's nice and big. Then you're going to hit print screen. And then you're going to go down here and open it up in Paint or whatever you've got there. And I always end up with Mark's ugly mug on there.
Oh.
So then we go back to this and we read that we have 75 degrees. See this stupid screen thing? It's always in my way.
Well, it does that to me too when I was sharing it.
Yeah.
I get over to the left or up.
75 degrees. Okay, and 50% relative humidity. So we read down here 50.
See, even after you showed me, I waited so long to do it again. I couldn't remember how you showed me.
You just do it this way.
I did guess it right though. Whatever I did, I figured it out.
Just going through right there. All right. So the question is, how many degrees would it have to rapidly fall in order to reach dew point? All right. So if we're falling, then we're going in this direction. All right. So we're going to start at this point, and no, we're not going to do that. We're going to use a line, and we're going to start at this point, and we're going to go as level as we can across through there, try to follow these level lines there. And then what we do is we grab another line, and right where it hits this point here, we want to go down, and it appears to be we got about 54 degrees. And what I'm reading is right there. Okay, so we took our line up at 75 degrees. We had our relative humidity at 50%, and then we were moving in this direction because we're moving colder. Then wherever it crosses the dew point line or the 100% saturation line, then basically we just follow that back down to find out that we got roughly 54 degrees.
Whoa, go back a second. Oh, did you go back to the paint? I'm trying to,
Oh, I'm sorry, I closed it.
I gotta have a record of this, or I'll never remember. I know you put this on the final, and I'm like, I gotta memorize how to do this. Damn pen. Okay, I got it.
Well, hang on just a second.
I just trying to. I need to highlight fall, so drop goes left. So if you worded it where it increased, you go to the right.
Yep. I get that line exactly.
Wait a minute. How can you go to the right? You'll never hit the dew line.
Well, I wouldn't give you that. I'd ask you, what is if I said we heated up to 85 degrees, what would be the dew point, or what would be the relative humidity? I want you to real quickly here, I want you to hit print screen on your keyboard. Mark.
Yeah.
Hit print screen.
Oh. Hold on a minute. Damn it, where you at?
Okay, go to paint.
Oh, Jesus wants to save to OneDrive. No, I don't want to save to OneDrive, you crap. I don't think my computer's set up to. No, thanks. Hold on a second.
So if nothing else, take your phone out and take a picture of it real quick.
Hold on. Wow, damn, that's long. Okay, got it.
Cool. All right. So if I said that we started out at 75 degrees and 50% relative humidity, and the temperature raised to 85 degrees, what would be the relative humidity, which means that we're going in this direction? Then we're going to have to really look closely at this chart here because here is 40% relative humidity. Here is 30% relative humidity. And that is a little over center. So technically it should be about 36%. Do you see how that is?
Okay, so that's some interpolation going on there.
Yeah. I mean, it's a little above half. Here's 30, here's 40. It's a little above half. So you could technically, I mean, I would probably put it in as you'd have a range to hit. I wouldn't say it has to be specifically 36%, but so, I'm just guessing because it's a little above half. So that would be how that question runs. I wouldn't ask you how far does it have to go to the dew point, because it never would hit the dew point.
Right. Well, that's good. You gave both examples, so we're covered.
Okay, cool. A proper house envelope consists of 3 barriers. Pick the correct 3.
I got those correct. It's thermal, air, and moisture. And this is a weird way of memorizing. It's TAM, which is my father's initial, so I'll never forget it.
Damn. There you go.
You got to use those methods, or it's too much information.
Absolutely. Absolutely. Wicking is a natural phenomenon where liquid travels up a porous material. This is known as
Capillary
reaction. There you go. Okay, cool beans. All right. Any questions?
Well, after 5 attempts, I did good.
Okay. Sweet. All right. So let's take a break. When we come back, we're going to talk. We're going to continue our talk about advanced framing.
Thank you.
Recording. And see if I can hide this thing. There we go. All right, so let's recap what we were talking about the other day. We're looking down on a stud wall. We have, and Eli's trying to call me in the middle of the thing. Let me just answer this right quick. Hey, buddy, I'm in the middle of a class. Let me call you back. Everything okay?
Mom told me to ask you about the internet.
Oh, it just was freezing. So I don't know. Maybe because I'm on Zoom.
So is it still freezing?
I don't know. I'm on Zoom now.
But it's not freezing on Zoom?
No.
Okay, then. Yeah,
Okay.
fine.
All right. See you. Bye. So we're looking down on this, and conventionally we would have a stud, we would have a spacer, we would have another stud on here, and then we have the stud in the butt wall, and then we've got just this little bit of area right here that would be used to put a drywall on. We got to make sure that we put this piece on before we put this piece on. So, this is old school. What we want to do nowadays is we want to do a California corner. An energy efficient corner basically is what we're trying to accomplish there. And so, wait a minute, sorry, damn. Make sure I get this right. Well, for some reason, I'm lost my mind here a second. Let me look at it. Jeez. Of course, I don't have it. There it is. So yeah, I'll just show you that picture. So here is the energy efficient corner that we have on there. And, doing it in this fashion here, then if we try to put our siding on and we don't have plywood on this corner, then we have nothing to nail our siding to at this point here, because we've got our trim boards on there. So we've got to really pay close attention to that and make sure that we have something here to put that on there. The other day we got into the T's in old school. we have the through wall, we've got the intersecting wall. We would have a stud in here that's going to be on the intersecting wall. And, you know, just as, like I say, old school, then we would have this T in there. And this one here could be a full stud, or it could be blocking. Most of the time it was a full stud. You know, back in the 50s, 60s, 70s, 80s, into the 90s, even we started, we just, I mean, you know, studs were 75 cents, 80 cents a piece. And so that's something, let me put that in there where you can look at this. So when I started business, I was paying 80 cents for a stud. All right. Today, the last time I looked, they were $7.48 a piece. Now that's a stud. So that is a 2x4 by 93 inches. All right. So it's pre-cut for a single bottom plate and a double top plate. So when we look at that, we have a double top plate, we have a single sole plate, and then that stud is cut at 93 inches. So we have a total from floor to top of plate of 8 foot 1.5 inches. And that way we can, you know, we've got some room to put our gyp board on, and 1/2 inch on the ceiling. And, you know, we've got an 8 foot, or we've got basically 2 4-foot pieces that would go on in this fashion. Generally they're laid down, and that gives us a total of 8 feet there, which if you do all the calculations, then you end up with a little space down here at the bottom that you know, is open to the bottom of the stud. But then if you put a 3/4 inch hardwood floor on it, then that leaves you with about a quarter, and you're all said and done there.
Or carpet.
Or carpet. Yeah, if you put carpet on it, then you've got a lot more space down here. You've got about an inch there. So you know, this is a bad idea because, you know, they put that sheathing on, and then this space here, we can't get insulation into it. So so what we want to do is do one of two ways that that can be done. Got the intersecting wall in here, and we're going to say that this intersecting wall is a 2x4 wall. Whoops, sorry. 2x4 wall. Then we could put a 2x6 here going all the way up, and then that way we can shove insulation in between our studs and get that insulated very good even after the sheathing is going on. Or we can do the ladder type, which means that wherever this stud lands and wherever this stud lands, then we run a ladder up through there. I think I got a picture of that somewhere. Or not. I could have swore I had that. There's that corner that I was telling you about, 2 stud corner, insulated corner. There's the ladder. That's why I knew there was.
Oh,
So
yeah.
see how the ladder goes in there. And generally, you know, I don't know, you know, different people do it different ways, but I always
The ladder'd be cheaper, wouldn't it?
I don't know. Well, probably because it's you know, it's made out of 2x4 material. But it all depends on what this distance is. Are you going to need 1 or 2 studs? I mean, you know, 1 2x6 down through here, attached at the top and the bottom, and then you know, might be cheaper. I don't know. But as a general rule, I always put 1 basically at the top, 1 at the center, and 1 at the bottom, and it was a done deal. He's putting it here. I'm assuming that he's going to put 1 here, and that way he can possibly toenail into the plate here and toenail into the plate here to have that connected. Now, with advanced framing, we try to eliminate more wood. Or, you know, when we've got all this wood in here, then more wood means less insulation. And so one of the ways to lessen this or to increase our insulation is to change this on center spacing. All right, so typically it's 16 inches on center, meaning that, you know, from center to center it's 16 inches. We increase that to 24 inches on center. And by doing so, we're going from about 17% framing down to about 12 or 13% framing. And that allows for more insulation to be placed in the wall. So,
And you're going to be using a 2x6 when you go to 24.
Yeah, you can't, that's load bearing, so you can't do that unless you up your stud size.
you can still actually do a 2x4, but you have to do you got to make sure that everything lines up. Let me explain that.
You mean you have to have your joist centered above your stud so that you don't have so much weight in between?
You got it.
Okay.
Okay. So let's say that we're gonna do our floor. All right, so these are floor joists. We're going to have our subfloor on there, and then we're going to have a sole plate on here. And then we're going to make sure that our studs are exactly the same spacing. In other words, they're right on top of each other.
Match the floor joist.
Exactly, match the floor joist. Then, by doing this, we can eliminate a double top plate as long as our trusses are directly lined up with this. Okay, so these would be our trusses, and everything is lined up, and all loads transfer completely down all the way through the entire building.
So that's code acceptable as long as alignment's in place?
Yes. Yep. Now, the reason that we put a double top plate is a couple of reasons. One, we tie the walls together, and two, you know, this might be, you know, it might be 16 inches on center studs, but then up here on the roof, we might have, I mean, it could be 19.2, it could be 24 inches. I have seen as much as 32 inches on here spacing. I mean, you know, so this transfers that load and allows that force to be placed and run down and to transfer that load. So that double top plate is extremely important when these do not match up. When these do not match, then, you know, this is a must. You have no other choice. You'll get called out in a heartbeat on that stuff. Now, let's think about that that intersecting wall, for instance. Okay, when we stud this up, we have that intersecting wall here, and you know, we've got our studs in here, and we're going to do a top plate. We're going to do a double top plate. So the first plate is going to go all the way across. And so this one is going to be justified for the intersecting wall. And of course, this one is going to be justified for the through wall. Then we're going to go on top of that. And this one, this double stud or double top plate is going to go on top of the through wall. In other words, this is going to run across the through wall, and we're going to tie this in with a couple of nails here so that the top of this doesn't move. Then we're going to just, this other one that we're going to put up, you know, it just takes up the space. We really, you know, if we were lined up with our rafters on that technically we wouldn't need that double top plate, only to tie in this wall here. So, you know, this is really crucial. Now, if we get rid of the double top plate, how do we tie the intersecting wall into the through wall at the plate? And that is where we end up using what is known as a gang nail. All right, so a gang nail, and I'll show you a picture of it. A gang nail is a piece of metal that has a whole bunch of serrated edges on it, little points in here that have been bent over so that they can be nailed in place. And, you know, you see this a lot of times in trusses. They use these to hold trusses together, but these also can be used on the top of the walls to attach those two so that we don't, so we have good rigidity up there and they don't come apart. Let me just do something. Gang nail on.
Before gang nails, did they just use to cut a stubby 2x4?
Not a stubby 2x4. Let me look up something right quick.
Why would you have to run one the whole length if all you're worried about is just attachment at the joint?
To get the same plane. Hang on just a second. Let me think about how to word this. Intersecting wall framing. Maybe this one. Okay, in this picture here, they're doing a, this is, I don't know if this is an intersect, looks more like a corner. So this is the butt wall. And that means that that stud stops right there. And I might be wrong on that. Let me look at it again. It's kind of hard to tell. Anyway, so let's say that this is the butt wall and this is the through wall. So this double plate here goes all the way to the outside of this wall here. Okay, it passes the intersecting wall. So when we go on this one goes all the way to the outside of this wall, and this one stops right there. Okay, so if we didn't put this one on, this would be at, we'll call this 1.5, we'll call this height 1.5 inch. And this one would still be at 0. All right, so when we're putting our joists on here, or I mean our rafters on here, or our trusses, then if we had it, when we came to this wall, then if a truss fell on this intersecting wall, excuse me, then this would be 1.5 inches higher than this wall over here. So we just put this spacer in. And again, this spacer, if our rafters do not hit directly on here, we have to use a double to transfer that that load down on the stud. And that has to be there. But if we were to you know, line everything up perfectly on there, then the only reason that we put this on there is to keep this height the same all the way around the house.
Consistent.
Does that make sense?
Yeah.
Eric, I've been told that in situations where you're trying to use a single top plate, and you know, especially if you're trying to do 24 on center with 2x4s, that you need to add more diagonal bracing.
I could see that.
I was just thinking that because it's weaker.
And, you know, not rely on just the plywood or the OSB, since that's, you know, kind of a long stretch.
If you happen to cross over that information, send that to me. I'd like to read up on that a little bit more too. Well, I'm not finding what I was trying to find, but you know, again, you know, talking about that diagonal bracing, in this particular picture, notice that he's got some diagonal bracing just sticking out in here. This is all temporary. This will be taken down, but he's got the, you know, OSB on here as well. So what Danny's talking about, and I don't want to be putting words in his mouth. I just want to make sure that I'm clear and you guys are clear. So when we're doing the when we're doing 24 inches on center, we're using less wood, meaning that we've got a longer space. We've got a single top plate. Everything is lined up. And we need to put more bracing in here so that these do not collapse. Am I correct in assuming that's what you're talking about?
Absolutely. And, you know, when we're relying on a 4x8 sheet of plywood, often if it's only going to catch the middle part of those two outside studs and you're relying kind of on a toenail of a sheathing nail,
Yep.
you don't have as much structural capacity in each sheet as you would if it was crossing 4 studs.
Right. So when we're talking about doing the 2 foot on center, depending on most of the time, okay, so let me say this. Plywood was originally designed so that the grain of the plywood, of both sides of the plywood, run in the long direction. Okay, meaning that we end up with an odd number of plies on here so that we end up with both the grain of the inside and the outside running in the long distance of it. So with that being said, plywood actually is designed to be put on in this fashion. All right, but it's not. In a lot of cases, it's put on in this direction, meaning that it only covers a couple of studs. If it's 2 foot on center, it's only covering 2 studs. It's covering the center of this one. So you got half a stud there. It's covering all of this. And let me put it in a different color. And half of that one. So we've got a full here, we've got a half here, and we've got a half over here. So that's only 2 studs really. And especially when you're over here, you're talking about 3/4 of an inch that it's landing on this. Hopefully, pray to God that we've got all this lined up correctly. I've tried to hit a 1/4 inch space, meaning that this was off just a little bit. And you know, I had a 1/4 inch space over here and 3/4 inches on this side. Not 3/4, had an inch and a 1/4 on this side. So anyway, you know, getting this dead on center in advanced framing is super critical. And by, you know, going down through here and you're putting a nail at that 3/4 inch space right there, you know, you don't have a whole lot holding on. So if you've got a lot of downward pressure on here, a force, let's say, for instance, God forbid that it was a 2-story or 3-story house on this type of framing, then this is super critical here. And wherever these joints are, we would need to have some sort of diagonal in here to keep this from pulling out. Because I'll tell you what, if you've ever nailed plywood, you know, on the center of a stud like this, a lot of times when this goes on, you have to really kind of come back a little bit and toenail that nail into it in that fashion right there. If you go too close, then it's going to tear out. It's going to be worthless. And I've done this on floor joists where I just nailed it in straight. And then I stepped from here over to another one and shifted this, and it tore out. I've had that happen many a time.
Same thing with drywall.
What's that? Yeah,
Same
same
thing.
with drywall. Yeah, yeah,
Drywall's hard, it's not as strong, so
yeah.
you don't have any strength there.
And there are nailing patterns that are listed in the building code as to how many nails you need to put in a piece of plywood. And so when I'm teaching, I'm just, I try to come up with ideas to keep it simple so that when you're on the job site, you're thinking about it. So when you're nailing along the edges, when you're nailing along the edges of this, use the rule of thumb. That's how far they ought to be apart from your thumb to your hand there. But when you're putting the nails in the center here, use the pinky rule. So they should be about that far apart. So
Never heard that.
and
Unless you're building on the coast and then put one everywhere there's a dot on the OSB.
yeah. There are certain, like California, for instance, they're so strenuous with the code. So you will see, they, especially Advantex, let me get rid of this.
Do they make ribbed nails that would hold as well as a screw that you could use?
They make,
Most sheathing nails are ring shank.
They're what?
They're ring shanked, like you're saying. They have those.
Oh, yes. That makes sense, because then it just won't pull right out.
so at Advantex especially, they sell their plywood and they've got these little dots all over the place. And then you'll see the dots through the center. And then they'll have a diamond on it as well. And when the building inspector comes in play, he better see a nail in every one of those slots or he'll call you out on it. So, and there's, they usually put these on at 16 inches on center, at 19.2 inches on center, and 24 inches on center.
A reference to earlier, do they now make plywood with the grain the other way where you can put it on horizontally?
Right now. I'm sorry, say again.
Do they make plywood with the grain the opposite direction so you can install it horizontally?
No.
Choose.
No, all plywood is got the grain going in that direction. So when you read, and I can't think of the organization that, that the National Plywood Association, I can't think of what it's called right now.
Mhm.
So when they talk about plywood, they will specifically say that plywood should be hung with the grain running between the supports, meaning like this. Okay, so the grain is running between the supports. If we put it up this way, the grain is running with the supports, parallel to the supports. Maybe it says perpendicular. I think it does. Perpendicular to the supports, because there is an odd number of, I'm just going to draw 3 here, because there's an odd number of plies, then it's going to be stronger in this direction than it would be stronger in this direction than in this direction. Does that make sense? But because, most of our walls are somewhere around 8 foot, this is the preferred method of putting the sheathing on, where, in reality, this is what we should be putting it on, and it just don't happen. We do that on a floor. We do that on a roof. Why not do it on a wall? I don't know.
Yeah. Well, drywall's done that way.
Sometimes I've seen them put it the other way too.
Really? Wow.
Yeah. Oh yeah. Absolutely. Okay, so this is a really cool little site that I found. The do's and don'ts. David's do's and don'ts. Advanced framing. Let me get back to the beginning. Maybe that was the beginning. Okay, so don't bother. So He's saying don't bother about windows on layouts. Don't bother with using fewer cripples. Don't bother with using a single top plate, and don't bother with using header hangers. So let's go back to our little drawing here, and okay, so true advanced framing. So if we're doing advanced framing, then we're doing 24 inches on center. And if we're doing that, why not use 24-inch windows? So we can put a window right there and we haven't changed a single stud whatsoever. We can go down here to the next one and we can put another 2-foot window in here. Generally, these are like casement windows.
Well, it's actually 22 and a half.
Yeah. But they make windows that will go in between these, and you don't have to change a stud. Meaning that if we were using the regular type and we wanted to put a larger window in here, then we have to put cripples in. And if this is a bearing wall, then we'd have to put a header across the top of it, right? So we have to change this out just a little bit. So like I say, a true advanced framing, windows are crucial to making sure that they fit in between that. Now, what about a door? Well, a door is going to be obviously bigger, but what we want to do is we want to make sure that we have the placement of that door so at least one side fits in that 2x spacing, where we only have to add a stud and eliminate, one of the studs that's in there. So, we have to pay real close attention to how we lay out our stud and how we lay out our windows. So if we're doing advanced framing, we just don't get on the job site and start slamming out studs like we normally would. This has to come from the design phase. So, when you're doing a true advanced framing, you might have a framing plan for that. And let me just give you an idea of this. So we do roof framing plans where we tell them, where this is going to be. And actually we do floor framing plans, second floor framing plans, when we use large timbers. So these are 4x8. Actually, these are 6x8 timbers. So we have to plan ahead to find out where our baths are going to go, where our toilets are going to go, so that we don't want to cut one of these. So if we have to shift this one way or the other, we can do it in the plan on paper and then send it out, and they can follow this to lay it out. Obviously, you see that on one side we have 3 1.5 space over here, where over here we have 2 6, and then these are 32 inches on center. We go to the roof, the same deal. We do this so that they know where all of these things are going to run and hit and fall. Now, when you get into much more complex systems, such as this house here, this house is using a different type of method of framing. They're using steel trusses on posts. So in this particular house, we had to plan out where our posts were going to go. And, they have to follow this to the T when they lay out for their foundations, when they lay out for their wall framing, everything, so it will run out, because there's going to be, typically there's no studs in between this, because we're going to put studs. That came out wrong. We don't have to have bearing studs. All of this inside is bearing free, so we don't have to have big headers in there, and we can slam insulation in here. This is, we're using 2-foot. Well, we could use 4-foot on center. I wouldn't advise it, but I'm just saying we could, because all the bearing is on the posts. And so, if you get one of these posts wrong when you're trying to frame this, then when you get to this monstrosity, and I'm telling you, this has drove me nuts because I've only done this twice before, and it's a different thought completely because these actually run in a different direction. You're using the truss as the support, and you're putting purlins in at 16 inches on center or 2 foot on center to hold your plywood. And so to draw that is freaking crazy.
Too bad Revit will do all that automatically. It doesn't have a feature to do that, does it?
No, not this style. Now, a conventional roof, yes, but
Okay.
using metal joists, no.
Will it do wall framing? I hadn't found that option.
It does. It will.
Okay, cool.
It'll calculate and tell you how many you need. It'll do your estimating for you.
Oh, it won't draw it then.
I don't think so, but it'll tell you how many you need to order.
Okay.
So that gives you an idea about that. Now let's continue on. Running out of time. So David's list to do is 24 inches on center, 2 stud corners, the right sized header. All right. So the right sized header is, another thing that is super crucial, and you can go to your building code and figure out that very easily, or of course you can hire a engineer that's going to cost you out the yin yang, or you can go to if you're using an LVL, go to that LVL manufacturer that you're going to use, and they have tables in there, span tables that you can use in there. But in here in the code book, we can go in and we can figure out how many, what can we do? And it's going to tell us that we can use a 2x4. The maximum spacing is going to be 24 inches on center. A habitable attic assembly supported by 2x4 is limited to a roof span of 32 feet. So, there's going to be criteria in here that eliminates that. So if we go to 2 stories high, we can't use a 2x4 anymore, or we can't do it at 24 inches on center. We have to go to a 2x6 to do it 24 inches on center, or we can do it a 3x4 or a 2x5. Go find me a 3x4 or a 2x5, for the same amount of money that a 2x4 is. And you can call me Orville Redenbacher. So when you go to 3 stories, then that eliminates, even a 2x6 being used at 24 inches on center. So when you're using your headers, use the tables 602.71, and where we are in 602 point, yeah, so so here is our girder and header supports. We have to consider our snow load. All right, so if we're in Florida, we're using this. If we're in Montana, we're using this. So we could, easily use the 50 PSF snow load. When you're doing these, I always stress that you want to do these at that 100-year snowstorm that you get, like we had back in 1993. So it's you don't want this thing to collapse because of one stinking snowstorm. But anyway, so it gives you, and I like using the 2012 model of the code because it gives me little pictures here. Nothing has changed in this chart from 2012 to 2018, except they took the pictures away. And I don't know why they took the pictures away, but so you can go in here and you can figure out what length that you need, what size you need. Do you need 2 2x12s, and a 28 foot wide house? Then we're going to have the maximum span is going to be 7 foot 3 inches. Different class for this, but I just want to kind of give you a sum of what is expected when you're trying to figure out these lengths. Now, once you do these and figure out what those are, you want to insulate the crap out of them. So basically what I'm saying is use the I try to go with the least that I can go with. So obviously down here, I've got 4 2x12s and I can go for a longer span. So if I'm using 4 2x12s and a 2x4 wall, then that's going to be wider than my wall. So there's nothing there to insulate. And I'm going to have a cold spot there that's going to allow for heat transfer to cross through there. Whereas if I'm doing smaller spans and I can get by with 2 2x12s, then I have a little bit of space that I can put some insulation in there to eliminate that movement of heat through there. One other thing to be said, and I think this was brought up in one of the PowerPoint presentations, is the use of seal. So, going back to the double top plate method that we had here, this is a super big place for air, or excuse me, for heat transfer to go across. But if you take a strip of seal across through there, then you can eliminate some of that heat transfer by cutting off and making a thermal break there across through that. And the same goes that if you have a gang stud. So what are gang studs? So when we use gang studs, we might have a certain place, and I don't think I've got a gang stud on this at all.
They gang up on each other.
They do. So yes, I do have a gang stud. So let's say, for instance, right here, I've got to have a gang stud on. Let me go back over to this. There. So I've got a big old window here on the gable side of it. And because I'm using rafters instead of trusses, then all of this is considered a bearing wall as well. So I've got to have a gang stud going through here to support the ridge in here. So I put that gang stud in there, and you can see how, we've got to have a header here to transfer all of that force down to either side, but we've got that gang stud in there, which is a solid piece of wood going from the outside to the inside of the stud wall. So by putting that piece of seal on there, then we can eliminate that transfer. And, if we were really smart, we'd do the same thing here.
What's seal?
What's that?
What's seal? I don't think I've ever heard of that. Is it like a piece of wood or a bonding agent?
It's a piece of rubber.
Oh, okay.
Seal.
Now, is that the generic name, or is that a manufacturer or a brand?
I've got 2 different companies here calling it the same thing. So let's go back just a second. Actually, wait a minute. Let me just stay right there where I'm at, and I might find a better pick there. So seal is made to go on the seal between the foundation and where you put, where we've got wood going in. Okay, so we've got the foundation, and then we're going to put our stud wall on that. We put a piece of seal there to eliminate 2 things. One, any capillary action going up into the wood, and eliminate any heat transfer.
Is that, you said it's rubber?
No, it's foam.
Oh, it's a foam. Well, it looks like it's backing on it, or.
Well, that was something different when you were looking at that picture.
Okay.
I don't even know where that picture is now, but yeah. So that's something different. Don't look at this black stuff. Just look at that blue stuff right there.
Okay, the blue stuff is the seal.
That's correct.
Is it well, do you have to custom cut, or does it come in?
See how these lines are on there?
Yeah.
You can buy it 3.5 and 6 or 5, 3.5, 5.5, maybe 8. I don't know. And you can just take and rip down through these to get what you want.
Okay.
Or you can just put it on there and forget about it. And some people go ahead and put it on the bottom. They'll staple it onto the bottom of it before they set it up into place.
Well, that's a smart way. Yeah.
Okay, guys, we have run out of time today again. So today is Wednesday. So have a great weekend, and Monday we'll continue on advanced framing methods.
All right.
See ya.
Ow.